Hello everyone, I am Sumalata. In today's class, we are going to discuss about sodium thiosulfate. If you want to see and learn previous topics related to this chapter, please check in playlist. You will get complete information from your NCERT, also academy books. Okay, don't skip. Okay, just watch complete video and make perfect notes, then get more and more knowledge along with me. Okay, I'm trying to share each and everything present in your textbooks, academy textbooks or NCERT. Okay, if you feel useful and informative, please do subscribe and share these videos to your known people. Like these videos, mention your words in comment box. Okay, then we will start our class. Sodium thiosulfate is also known as hypo. Sodium thiosulfate is also known as hypo, HYPO. It is also known as sodium. Is it visible? Yes. Sodium thiosulfate. Hypo or sodium thiosulfate. Its molecular formula is Na2S2O3 is its molecular formula. If you take hydrated form of hypo, you can write along with these 5 water molecules. That's it. Okay, yes, this is the molecular formula of hypo or sodium thiosulfate. If you take a structure of sodium thiosulfate, it is looking like this. See, sulfur have double bond, and also this sulfur going to be attached with one oxygen by a double bond. This is O minus and this is also another O minus. The sodium atoms present in the form of Na plus, they are not directly attached with oxygen atoms. So this is the structure of hypo. Here you need to remember oxidation states of sulfur and another sulfur. Nothing but 2 sulfurs are here. Both are not having a similar oxidation state. Both are having different oxidation states. So you can see this one have -2 oxidation state, this one have +6 oxidation state, because here see, this is attaches with the oxygen, this is having -2, -1, -1, 4, and this is the -2, 6. So that the middle sulfur have +6 oxidation state and this one have a -2 oxidation state. If you see what is hypo, this is the oxy acid of sulfur. This is one of the oxy acid or oxo acid of sulfur. How can you tell it is an oxo acid or oxy acid? Because the bonds present between sulfur and oxygen, then we can call them as a oxy acids of sulfur. Okay, in any oxy acid, if you, here we are taking sulfur, that is the reason must and should bonds present between sulfur and oxygen, then only we can tell it is the oxy acid of sulfur. Okay, it is the least acidic and so that we can call it as the basic in nature. So this is the oxy acid or oxo acid of sulfur and also acting as a base. Okay, then coming to the preparation methods of sodium thiosulfate. First one you can see, first one is reaction between Na2SO3, sodium sulfite reacting with sulfur, solid sulfur. So you will get Na2S2O3. Remember, this is the sodium sulfite. Okay, this is the first preparation method. Second preparation method, you can see the same sodium sulfite Na2S2O3 reacting with sodium sulfide. This is the sodium sulfide. Okay, that is the sodium sulfite. Along with this iodine also there. So you will get sodium thiosulphate Na2S2O3. Along with this you also get sodium iodide in 2 moles. Okay, these are the two preparation methods of hypo or sodium thiosulphate. Okay, first preparation method is the sodium sulphate reacting with sulfur, you will get sodium thiosulphate. And second preparation method, sodium sulphite reacting with sodium sulphide along with iodine, then you will get sodium thiosulphate. On the previous points you can also see one more time. Sodium thiosulphate, also known as hypo, its molecular formula is the Na2S2O3. If you write its hydrated form, along with that we need to write 5 water molecules. Okay, it is the one of the oxy acid of or oxo acid of sulfur, because it is having bonds between sulfur and oxygen. And another one is it is acting as a base. Okay, it is the structure of thiosulphate, sodium thiosulphate, and oxidation states of sulfur -2 for that one, and +6 for second sulfur. Okay, these are the preparation methods. Then we can see about properties of sodium thiosulphate. Yes, now we can see about chemical reactions along with properties. When we are going to use that particular chemical reaction, for any chemical use is there. Okay, you can see chemical reactions. First one, hypo reacting with Na2S2O3 reacting with chlorine along with this water also, then you will get Na2SO4 and 2 moles of HCl and sulfur. 2 moles of HCl and sulfur. This is the reaction takes place between chlorine and sodium thiosulphate. Actually this reaction we can also called here hypo acting as an anti-chlor. This what is anti-chlor? Actually if already bleached fabrics are there, for those bleached fabrics, if any extra chlorine is there, we are going to remove that extra chlorine by using this hypo. Okay, so that here see sodium thiosulphate hypo reacting with chlorine, you will get sodium sulphate and hydrochloric acid and solid sulfur also. See, it is balanced. There are not 4 oxygens, 2 sulfur atoms, 2 sodium atoms and 2 chlorines and 2 hydrogens. Okay, this reaction used in a anti-chlor. Okay, second reaction, if you see reaction with HCl, Na2S2O3 reacting with hydrochloric acid, nothing but HCl. So you will get 2 moles of NaCl, sulfur dioxide gas and water, along with this solid sulfur also. Remember, this is the reaction, hypo reaction with hydrochloric acid. So here what happens, sodium chloride forms sulfur dioxide gas, water, along with these two solid sulfur also will form. Generally this reaction helpful to differentiate 2 ions. Those are what? See, first one is S2O3 2 minus thiosulphate ion forms water, sulfur dioxide and sulfur. If you take SO3 2 minus sulphite ion, you can take, it will form water and SO2 only. Okay, so that by using this reaction we can easily distinguish the differentiation between SO3 2 minus sulphite ions as well as thiosulfate ions. Okay, first reaction used as an anti-chlor. Already bleached fabrics are there. If any extra chlorine is present in that bleached fabrics, we are going to remove by using this reaction, nothing but hypo. Okay, second reaction useful for the differentiation between, we can easily identify the differentiation between thiosulfate ion as well as sulfite ion. Okay, yes, coming to next preparation methods, not preparation methods, next properties. If you see next chemical reaction, it is also used in complex reactions. That means if it reacts with metals, then it will form complexes. You can see few examples about those reactions also. So complex reactions, if you see hypo reacting with Na2S2O3 reacting with AgNO3, silver nitrate, this one is the silver nitrate, remember this is hypo, you will get, see here you need to take 2 moles, so Ag2S2O3, Ag2S2O3, along with this you will also get 2 moles of NaNO3. Okay, this is the silver thiosulfate. It is a white color, it is in white precipitate, this white precipitate soluble in water, so that you can also write like this. If it reacts with water, then you will get Az2S, silver sulfide, along with this silver sulfide. Next one, see what are the remaining here, Az2S went out, then remaining one is the H2SO4, sulfuric acid. See, silver sulfide, this is the black precipitate, PPT means precipitate, you just understand like that. Okay, this is the black precipitate. And next chemical reaction, if we are taking excess of hypo, what will happen? See, excess of hypo, Na2S2O3 2 moles, if you take the same AgNO3 in limited quantity, you will get soluble complex Na3AgS2O3 taken twice. This is the soluble complex, and remaining one is sodium nitrate, NaNO3. This is the soluble complex compound. Okay, soluble complex. Then this soluble complex used as a fixing agent in photography, so we can also tell which complex we are using in photography. That means then you can immediately tell this one. Okay, yes, this is about if hypo reacting with silver, these 3 reactions you just remember. And then coming to next chemical reaction, it is also reacts with neutral FeCl3. If hypo reacts with FeCl3, here also complex will form. That complex is the pink or white in color. You can see Fe plus 3 ferric ions. Before that, you can also try to understand this one. What is that? FeCl3, if it is going to be ionized, Fe plus 3 and chloride ions will form, and also hypo, Na2S2O3 is also going to be dissociate, then it will also form S2O3 2 minus. Okay, the formed these 2 ions, this one and this one going to be react. See, Fe plus 3 reacts with S2O3 2 minus 2 moles you can take, then you will get FeS2O3 taken twice, whole minus, this is the pink or violet color. pink or violet color. Okay, this is the pink or violet color. Here the formed this complex will again reacts with extra ferric ions. So Fe plus 3, you can write here directly. So plus Fe plus 3, then we will get here for a saving place, so you can write like this. So you will get what? Fe plus 2 ions, 2 moles you will get, and the remaining one is S4O6 2 minus, S4O6 2 minus. Ferric converts into ferrous, that means it is here it is acting as a reducing agent, here acting as a reducing agent. And the last reaction, if you see last reaction, it is also used in iodometric test. That means here iodine converts into iodide ion, that means iodine going to be reduced. See, I2 reacts with 2 moles of S2O3 thiosulphate ions. Okay, then you will get 2 moles of I minus iodide ions, and remaining one is dithiosulphate, S4O6 2 minus. Generally here it will comes it need to comes 4 minus, but 2 electrons taken by this iodine, that is the reason it will comes as a 2 minus. Okay, these are the chemical reactions and properties of hypo. That means especially used in photography as a fixing agent, and also anti-chlor, and also in iodometric test, and most of the reactions it is acting as a reducing agent. I think you are all understand about this class. If you feel useful and informative, please do subscribe and share these videos to your known people. Don't forget to like. Okay, mention your words in comment box. Thanks for watching. We will meet in the next class. Bye. I love you.